There we go. So that Friday video lecture, that is required. You want to go watch that if you haven't. And that material is all about your macronutrients, or what you call macros. Today is more about energy balance, calories in, calories out, and vitamins. The vitamins are considered micronutrients. What are the three big macros in our diets, or macronutrients? I heard them in different orders, but proteins, carbs, fats. Why are they classified macro? Where's that word come from? Large. We need to eat large amounts of those, because those are going to become the major building blocks for building us. So proteins, carbs, and fats, and their details of what the different subunits are and how we get them and what we use them for, that was from Friday's lecture. Micronutrients, we do need those, but they're required in small amounts, basically to support different metabolic reactions that we have. Micronutrients are not really building blocks like macros are. So the micronutrients are vitamins and minerals. They are essential, but they are not needed in the big amounts that the macros are. So most of this lecture will be talking about micronutrients. Before we get to that part, I do need to say something about calories and energy balance. So probably everybody has heard of calories, and we know that some foods have more calories than others. What a calorie is, technically, is the amount of heat or the amount of energy that it takes to raise the temperature of a kilogram of water 1 degree Celsius. So calories are really a heat measurement, a certain kind of energy measurement. And our food calories are actually kilocalories. So there's a measurement called regular calorie. 1 regular calorie is the heat to raise a gram of water by 1 degree Celsius. That's a regular calorie. Our food calories are kilocalories, or 1,000 times that. So the amount of heat it takes to raise a kilogram of water by 1 degree Celsius. And I want to put up here, you don't have this in your slides, but it's just a nutrition label to look at. One of the things that I do on exam 3 is I put a nutrition label similar to this, and then I ask you questions about it related to stuff that I talked about in lecture. So the first thing I want to point out about this is, if this food has 230 calories, it's actually kilocalories. They just don't say that on the label. So the general public idea of a calorie is kilocalorie. This actually has 230 kilocalories in 1 serving. And I don't know what food this is from, but I think it's maybe ice cream or something. It's got a lot of fat. Well, it's got a large amount of fibers. It's probably not ice cream. It's got all the different macros. So it's got fat, it's got carbohydrate, it's got protein, 230 calories per serving. And then if you ate the whole container, it would be that times 8. It's like, I don't know, do you all learn about nutrition labels in high school or go over it? That's good. They've changed a lot of times since I've been in high school, but you can see here they've got the carbs section. So fiber is its own section. Sugars, that would be mono and disaccharides. And then how much added sugar. Protein, 3 grams, different kinds of fats. So the kinds of questions that some of the questions that I ask on the exam will be about a nutrition label and asking you some short answer questions about that. Whoop, too fast. So like other physiology with people, our physiology developed early on in human history, like during caveman days. Most of human history was back in caveman days before we had agriculture and cheap food and office jobs where we sit around. So our whole physiology is set up to conserve energy and be very efficient with the calories that we eat. So if we eat more calories than we burn, it's like calorie intake, that's what we eat. Expenditure is what we burn. We will store those calories as fat and we'll gain weight. If we eat fewer calories than we burn, we use our stored fat instead to make up the difference and we'll lose weight. It is basically that simple. There's some minor tweaks that you can do with nutrition, but it is basically calories in, calories out. And we're set up to be real efficient in putting on weight if we eat extra calories. Because in caveman days, that can make the difference between you living and dying when you run out of food later. So for individual people, individuals need different amounts of calories to supply their life. The amount of calories that you need to supply your everyday life is basically called basal metabolic rate, or BMR. Those of you that are exercise science, some of your upper level classes, you'll be able to measure your BMR and you'll learn more about this there. But the bigger you are, the higher your basal metabolic rate, because there's more of you to supply. There's more of you to burn energy to keep alive. Your surface area compared to your internal volume, that also changes it. So somebody like Hawken, who is both tall and kind of thin, you have a large surface area compared to the inside of your body. Yeah, it's just a fact. And when you have a large surface area compared to internal, you actually spend more calories maintaining your body temperature. Yeah, it's a good thing. Whereas if you're short and stocky like myself, I have a high internal volume to external surface, and I don't have to burn as much energy to stay warm. If you're in a pool all the time, that also I would think would increase your BMR because you're in cold water and you're having to maintain heat a little bit. Your BMR is also somewhat controlled by thyroid levels. So remember, we learned about thyroid hormone. It controls your metabolism and how fast you burn energy. If you've got very high thyroid hormone, you're going to burn more energy than if it's low. So all of that stuff, as well as your muscle mass, should put that in there. Muscle mass also affects BMR. And the higher your BMR, that means you require more calories, or you're going to burn more calories. So people with a high BMR are going to have a higher calorie limit for what their set point is. And it's a really cool topic. I don't have time to keep going on that, but there's cool, you can actually measure it by how much oxygen you consume. So some of you will get to do that in upcoming classes. There's another measurement related to energy balance, which is BMI. Almost the same letters, but BMI instead of BMR. And I think you all have grown up with this concept, and probably when you're in school, they measure it. What'd you say?
It varies.
It varies. Yeah, the accuracy of it does vary. I think one of the boys at one point, we got a letter home that their BMI was a little bit getting high at one point, like a letter home from school. You may want to watch this. BMI is measuring what's your ratio of height to weight to height, such that a person who is about 5'2" ought to have a BMI ratio between 26 and 29. Is considered the, oh, sorry, that's overweight. It should have, sorry, there's different charts that show like normal in the middle and then underweight over here. Sorry, I was reading that wrong. 22 to 24 is a healthy BMI for somebody that's 5'2". And then you can use this to classify, are people overweight? Are they obese? And it's just how tall you are versus what you weigh. There are different ways to be heavy. You can be heavy because you have a lot of muscle mass. You can be heavy because you're have a lot of fat mass. So it's not always that being high BMI is unhealthy. But most people that have a high BMI would be more in the overweight, obese category, unless they have a ton of muscle mass. So there are some caveats there. You can't always use BMI as an indicator of unhealthiness, but a lot of times it is. Okay, so that little section, it feels too short. It feels way too short, but there's some important info about vitamins and minerals that we do need to spend relatively more time on. How many of you are in nutrition now, or you already had it? How much do you all do about vitamins? Okay. I don't mind repeating it too much because there's so many of them. Probably need the repetition. Okay, so this section is going to be about vitamins specifically. So vitamins are considered micronutrients, and we do have to have them in sufficient amounts, but we don't need them in as big of amounts as the macros. And I've got up here that there's 4 macros. There actually are 4 macros. The 4th one is nucleic acids, and I wrote that in parentheses because we do need a decent amount of nucleic acids to help us build DNA, RNA, but it's like no one cares about that. No matter what food you eat, you're basically going to be able to build nucleic acids out of it. So we don't worry about people being deficient in that, or we need to supplement their nucleic acids in their diet. That technically is the 4th macro. So what vitamins we need them in small amounts to support particular reactions. And it's more than just a mineral. So I want to put here what minerals are. A mineral is just an element, like something that's on the periodic table, like iron, or sodium, or magnesium. A vitamin, we need it in small amounts, but it's more than just an element. A vitamin is a larger organic molecule. And they tend to have complicated chemical structures, which you don't have to know for this class. But that's the difference between vitamin and mineral. We cannot make the vitamins with our own body chemistry. We have to eat them. We can't build them, thus they are called essential vitamins. And we divide them into two really big groups. There's a lot of vitamins, they fall into two groups chemically. And they're called fat-soluble versus water-soluble. So on this slide, everything that's on this side goes with fat-soluble. And everything that's going to appear on this side goes with water-soluble. And this is basically like, what is the vitamin chemically like? Is it fatty or is it not fatty? If it's got a fatty structure on its own, it's going to dissolve in fat. And you would need to eat them with fat to absorb the vitamin. So our fat-soluble vitamins, it's very squeaky. They need to be eaten with fat to absorb. Or let's say for good absorption. If you take vitamin pills and you eat like a zero fat diet, you won't be able to absorb the fat soluble vitamins if you don't have a little fat in your diet to help them make their way into your blood. The fat soluble vitamins are not going to break down very easily. They're real stable. And they can build up in your tissues, and you can technically overdose on them if you have too much. That's not usually a problem for people, unless they're taking large amount of supplements and kind of winging it without telling anybody how much supplements you're taking. When you cook fat-soluble vitamins, they don't break down. They're real stable. Water-soluble vitamins are basically the opposite. They dissolve in water. Because they dissolve in water, they also are easy to get out of your body in urine. So if you've ever taken vitamins or gummy vitamins or supplements, and then about an hour later, you go to the bathroom and you see your urine is that, you know what that vitamin color is? It's kind of like a greenish yellow. You just peed out a lot of the vitamins that you just took. So you can't overdose on them. You're going to probably pee out the extra of your water-soluble vitamins. But these also, when you cook a food, it can destroy some of those vitamins. So they're acting in a very opposite way. You can't pee out fat-soluble vitamin because it's stuck in the fat in your body. So you can overdose on it. Make a note here on this page, right here, that the fat-soluble vitamins are A, D, E, and K. Vitamin A, vitamin D, vitamin E, and vitamin K are the fat-soluble vitamins. You could rearrange them and spell Cade with a K. And the water-soluble vitamins are the B vitamins, which there's a bunch of those. B vitamins and vitamin C. You need all of them, but those are their big categories. If you've ever taken vitamin D or vitamin E by itself, they're in those gel caps and they're oily inside. I don't know if you ever bit one to see what comes out of it, but it's usually in oil suspension because they're fat soluble. So each one of the vitamin groups, I'm going to go through some info about them. And this stuff that I'm going through is going to be multiple choice or possibly stuff on a nutrition label type of questions. Because there's a lot of these vitamins. So starting with fat soluble, we start first with vitamin A. Vitamin A is found sometimes, it's got different versions. There's different versions of it. So see how there's this ring, and then there's some hydrocarbon chain out here, and that's kind of all the same. All of these, carotene and retinal and retinol, they are all versions of vitamin A. And we get these from plant foods that are yellow or orange color. So carrots, sweet potato, certain kinds of squash, like red peppers, those would have vitamin A in them. And the most important thing about vitamin A that we need it for is that this helps build the pigments in our eyes that let us see. So if you're severely vitamin A deficient, you would be blind, which is sad. That doesn't happen too much in advanced countries because we put vitamins in school food, basically. When people have free lunch, they're vitamin supplemented. Vitamin A is also an antioxidant vitamin. So I'm not going to say too much about that. Just know that it is an antioxidant. And it comes out of those yellow-orange foods, and you need it for vision. Okay, next one, vitamin D. This one is a little bit special because we can make it. We can sometimes make vitamin D. And if we do, we make it out of cholesterol. And when the sun shines on our skin, we can do this chemical reaction that converts cholesterol into vitamin D. This requires you to have sufficient cholesterol and also sufficient sunlight. So people that live in northern places or like the high latitudes all over the earth. So if you live closer to the poles, you tend to be vitamin D deficient because you don't get enough sun. And the reason that you need vitamin D is without it, you can't absorb calcium and phosphorus. which means without vitamin D, you're going to have poor bone health. And this boy has a vitamin D deficiency in a syndrome called rickets. So all of these problems that he has have something to do with his bone growth is messed up. So he's got curved spine way too soon, kyphosis. All of his long bones are curved because they're not mineralizing. So if you can't absorb calcium and phosphorus, your bones don't get hard enough, and they're going to bend under the weight. And that condition is called rickets. This kind of problem could be totally prevented if he just had a little bit of vitamin D at the right time. So in the US, at least, we put vitamin D in milk. You ever notice that? Like if you buy milk, it says vitamin D enriched milk. It goes into commercially produced milk just to avoid this. If you go into nursing or social work or counseling, you sometimes will see US kids with rickets if their parents are like really drug addicted and they're not feeding them properly. And it's usually going to be if they haven't gone to school yet and had school lunch. It's really sad. We used to not have a rickets problem because like, oh, it's in the milk, everybody can buy milk. Or get free milk if your parents are able to take care of you. So rickets is vitamin D deficiency, and you need it for bone health, basically. Okay. The last two in the fat-soluble vitamins are vitamin E, and vitamin K. Vitamin E, we know that we have to have it, but nobody knows actually what it does, which is surprising. It's been known what it is for years and known that it's essential, but it's not quite known why we have to have it. Cereal oils just means that like corn oil has it, or any kind of oil that comes out of a grain. So if you eat grain that's whole grain, you'll get vitamin E. Vitamin K, if you like, this is so weird. We got vitamin A, B, C, D, E, and then it jumps up to K, which is weird. And the K letter comes from the word clot, not the American word, but the German word, which starts with K. So they named it vitamin K because it's needed for blood clotting. And that's all I'm going to say about those. So A, D, E, K, those are fat soluble. You could overdose on them. The foods that have them, you can't cook the vitamins out of the food. It's going to stay stable in the foods. And you won't pee them out if you have too many of it. Okay. Okay, next set are the water-soluble vitamins. So there's a bunch of B vitamins, and they have numbers, and together they're called B complex, and then vitamin C. So we'll go through some of those. B vitamins, as a group, you have to have those to convert energy out of your food. So they have that in common. You need these B vitamins so that you can burn your food for energy. And basically what they're doing is that these B vitamins are needed complete, your metabolic enzymes that do energy production. Like your electron transport chain proteins, B vitamins are a part of those. So if you don't have them, you can't properly run your glucose metabolism and make ATP out of your food. So they have numbers. Together, the set of them is called B vitamin complex. It's the set, B vitamin complex. And they all have some individual names that go with each number. I just like you to have seen the names, because some of these you might see on a nutrition label, like thiamine, riboflavin, niacin, niacinamide, pantothenic acid, pyridoxine, pyridoxal, biotin, cyanocobalamin. All of these are the other names of the B vitamins. That kind of thing I'm not going to have on the test, but I just want you to have seen the names. So they've all got a B and a number, and then they've all got some names in words as well. And that's the set of names. There's only one of these that I want you to know specific info about, which is B9. And I do want you to know the number, the name, and all the details, because it's so important for your age. So the word name of vitamin B9 is folate or folic acid. And this particular one is really important for building new DNA. If you're going to build a lot of new DNA and red blood cells and something called neural tube, you've got to have B9. So B9 is required for neural tube development, and I know you've already got that up there, but what neural tube is kind of the primitive start of the entire nervous system. So during embryonic stage of pregnancy, the starting material for brain and spinal cord and nerves, it starts developing as this structure called neural tube. And if you don't have enough vitamin B9 in early pregnancy, neural tube may not develop properly, which would then, as the fetus gets bigger, it could cause brain deficiencies and a lot of really bad birth defects. So getting enough vitamin B9 all the time is pretty important if you're female and you're at the age when you could be pregnant, even if you don't want to be. Getting enough B9 is really essential. And when people start taking prenatal vitamins, the real purpose for that is just to get enough B9. Like, you need those others too, but that one's super critical. And most, the average American diet has enough vitamin B9 if people are eating decently well. You'll have it in your different foods that you eat. Okay, and then our last water-soluble vitamin is vitamin C. Vitamin C. This one's English names can be ascorbate. You might see it on nutrition ingredients as ascorbate or ascorbic acid. Those are basically the same thing as vitamin C. It's specifically needed to build collagen, to produce folate, which is B9, to help produce B9, and to absorb iron. We need vitamin C for all of those things. Everybody knows that it's in citrus fruits. Like if you eat an orange, it has vitamin C. It's not just in citrus fruit. It's in strawberries. Tomatoes have vitamin C. Dark greens have vitamin C. And the deficiency for vitamin C is scurvy. When you have scurvy, you're going to have general weakness, anemia, because you can't absorb iron, joint problems, and tooth loss if it gets bad. A long time ago, when people figured out how to make incredibly long ocean voyages, the sailors tended to get scurvy because they hadn't had any fresh food in so long. The other food that they had basically the vitamins that they need, and they didn't go blind yet, but they started to have these problems because they didn't have vitamin C. So somebody figured out if you just take like one box of lemons on the boat, and you give each sailor a piece of lemon every so often, they won't have scurvy. It was the vitamin C. Okay, so getting vitamins, it's better to get them from your diet if possible. And if you eat a good, healthy, complete diet, you will get all the vitamins. Especially if you're eating dark leafy greens and sometimes liver, that combo has all the vitamins totally. Liver's not real popular in the US, but I used to think, how can Eskimo people or Inuit people, supposed to say Inuit people, how do they not have vitamin deficiencies? Because they live where it's so cold and there's snow so much of the time. How do they not? It's because they eat a lot of liver, and that gives them enough vitamins. So your great-grandparents used to have to take something called cod liver oil. It's gross. It's a good vitamin source. If you are in a special dietary group like being vegetarian, vegan, vegan needs to be added in there. If you're pregnant or if you're a child, it's more important to be careful about your vitamin intake. So if you're vegan, you probably already know this. Vegan diets will need to supplement B vitamins and vitamin D, because those are a little bit hard to get out of plant foods if you don't do eggs or meat in some way to get your vitamins. Okay. So I think, is this the last slide? One more. There's one more after this? Okay. I know there's not much on this slide, but it's because I'm just going to write a lot of notes about the important minerals. So the minerals that I want you guys to know for this class are the ones that we need in biggest amount. And those are iron, calcium, phosphorus, potassium, sodium, zinc, and magnesium. Those are not all the minerals, but those are the ones that we need in the biggest amounts. And certain ones of these, I'm just going to kind of list why we need them, what we need them for. So for iron, the biggest need that we have for iron is to help to build hemoglobin. That's not the only thing we do with iron, but that's the most important. So if you don't have enough iron, you can't build hemoglobin well, because iron is at the middle of the heme that makes hemoglobin that becomes part of a red blood cell. So we have to have iron for that purpose. Calcium we need for bone strength and also muscle contraction. It's got to come out of sarcoplasmic reticulum right at the end of muscle contraction. So if you have got dangerously low calcium, you almost be paralyzed in the muscular sense. Phosphorus we need for bone strength. Potassium we need for nervous system function. Also sodium we need for nervous system function. Zinc we need to help us produce healthy immune cells. And magnesium is an important part of metabolic enzymes. All of these are so important that our bodies will try to regulate their levels. We're going to try to regulate their levels in the blood so that they stay within a certain range. And if they're not in a certain range, we will do things to adjust the levels. So a lot of these, we're able to store them somewhere. So calcium and phosphorus, we store these in the bones. A lot of them is in the bones. If our blood levels get too low, we'll pull them out of the bones to keep the blood levels appropriate. Zinc, magnesium, and iron. We can store those in the liver. If we've got extra, we'll keep backup supplies in the liver. Sodium and potassium, we don't really store them in the body. Like, we got to keep eating them in their diet. If you've hunted and you put out a salt lick to make the deer come there, it's mostly these two. They got to get it in their diet. So like, salt. I'm gonna go eat some. Or if you put a salt block out for your cows, it's mostly potassium and sodium. A little bit of those others, but mostly those two. Last fact about minerals. if our levels of minerals are too high or too low, we're going to have some kind of body dysfunction. So keeping the levels balanced is really important. And sodium especially, we're going to spend a lot of time in later in March talking about sodium regulation as an example of how important it is to have the right levels and how we adjust the levels to try to keep from having a dysfunction. Oh, good. Yes, this is it's a very important slide. So I like to end on this. We tend to think like, oh, we're a rich country and we have enough food for everybody, and no one in the U.S. should go hungry or have malnutrition. Malnutrition is not always the same as starving. Malnutrition means you're not getting enough of all of these essential things. So you can have malnutrition and have enough calories, but you're missing vitamins. Or you can have malnutrition and be taking like vitamin pills and have all your vitamins, but you don't have enough protein in your diet. There's a lot of different ways that people can be malnourished. So it just means that you're lacking an essential component in the diet. And it actually should be one or more, not just one, but you're lacking something essential in your diet. Definitely people that just don't get enough to eat. And we think, oh, kids in other countries that don't get enough to eat. There are American kids that don't get enough to eat as well. They will have malnutrition at several different levels. Eating disorders, whether it's overeating or undereating, that's also an example of malnutrition. And then this one, I would just label it addiction. People who are addicted to alcohol actually can get enough calories from alcohol if they're at that level to stay alive, but they get really, really deficient in their minerals and vitamins. And alcoholism, malnutrition is its like own giant area. So those of you that go into counseling, that's something to be aware of, that it's not just that people are struggling with alcoholism, but they're also going to have a lot of health problems from the malnutrition. Drug addiction is the same. So people who are very, very deep into drug addiction don't care if they eat or not. And maybe they're spending too much on drugs and not enough on food, and they will have really bad malnutrition issues as well. So malnutrition is not just people who technically don't get enough food to eat. There's other categories of it as well that will affect your careers. So I will see you guys tomorrow for lab exam. Study, but don't stay up all night studying. Get some rest, eat healthy food,